The first step in answering this question, which has led to quite a lot of interest amongst our students, is to do the experiment. Another approach would be to solve it analytically. But first, the experiment. So this is the setup using an adjustable slit with a micrometer. And the idea is to have the micrometer set to 0 at the start of the experiment. Unfortunately, some of them have a 0 error, so I had to pick one where the 0 actually meant that the slit had a 0 size. I'm going to shine a laser pointer through this at the back and see what the pattern looks like on the screen. And then, in order to replicate the IB exam question, change the width of the slit and see what happens to the resulting pattern. That's the plan anyway. I'm shining the laser light through the slit, and the slit's open just a little bit to make sure that there's alignment. And it's hard to see in the video, but I'll change the focus now, but you can see that there's a little diffraction pattern actually on the door opposite. So that's the setup, and the idea is to change the slit width, making sure that the laser's shining directly through, just so you can see that's fairly wide. So we'll set that at a massive 0.5 millimeter, so very clear slit. When that happens, the spot on the screen starts to become really bright. There's still a bit of diffraction, even though that slit's really big. We can do another half turn. It's a 1 millimeter slit, and although the edges of the beam are hitting the slit, most of the energy is just going straight through. So I'm going to take this all the way down to a really narrow 0.2 millimeters, and that's giving quite a decent size on the door. So there it is, there's the pattern on the screen. Obviously that's going to look a lot better when it's photographed in the dark. So with the lights off, we can now see the pattern clearly, even though the camera is compensating for the darkness. Of course, a safety issue, it's probably worth mentioning now, that if you are adjusting here, you are potentially looking back at the laser, and you want to be absolutely sure that your eye is nowhere near the line of sight of the laser. That's also the purpose of this recess in the slit. You can see there's a really bright reflection happening, but the recess minimizes the chance of reflection coming back and causing problems. You can see a weak reflection off the black surfaces of the slit. That's picked up in the video camera. There is backlash in the threads of the micrometer, which means that if you change direction, those screw threads go through a dead space before they engage on the other side. And so it's really important to close or open the micrometer consistently in the same way each time as you adjust the slit. So here we're starting with the slit wider open at 0.2 millimeters, and you could debate in the comments whether that's a good idea or not. And the idea now is to stop it down to 0.1 millimeters, being sure to keep the screw turning in the same direction. And here it is, 0.1 millimeters. Clearly the pattern is both wider and dimmer because there's less light going through the slit because the slit has a narrower aperture, and it's being diffracted through a larger angle. So what light there is being spread out over a larger area on the screen. Now, looking at the still images, immediately we run into problems because the camera records in RAW format, and I used a fancy camera and it records in a RAW format that none of my software can analyze. This is a TIFF version, and I had to import the TIFF into MaximDL, and there's various other programs that can also do that. And here you can see the line profile. It's measuring in red, green, and blue the pixel value, whatever that is, analog digital units, so it's not calibrated in watts per square meter or lux or candelas or any kind of SI brightness unit, and it's also not linear. And you can see problems. So the red image is actually clipped. So despite my efforts, I still saturated in red. It's reaching the highest reading possible on the sensor. the blue and green images are actually okay. And so what we really need to do here is to look at the green image because it's better measured. There's twice as many green pixels in the biometrics, and it's got a value of just over 28,000 analog digital units. Now, I bracketed the exposure, so I took lots of different shots with different camera settings, and instead of just taking that measurement and comparing with the same setting with the different size slit, let me just show you what that looks like. So here we've now got the slit wider, and therefore the diffraction pattern is smaller, and it doesn't look brighter. I selected an image where actually we're getting very similar brightness to before. So the red again is clipped. I'm using the green channel, again around 28,000. And so to do the brightness measurement or the comparison, you actually have to compare the camera settings. One of these images was taken at f5.6 and the other taken at f11. That is 2 photographic stops, or 2 to the power 2 difference in exposure. And so changing the slit width by a factor of 2 resulted in a 4 times change in the brightness. And specifically having a wider aperture or a wider slit width means that we get an increase in the intensity of the central maximum, and it's proportional to the square of the slit width. So that is an experimental approach. It could definitely be improved by using Canon's CR2 RAW format, which can be analyzed directly in a linear fashion, and by not overexposing in the red channel and measuring the red channel. Obviously it's a red laser, so the green and the blue are not necessarily the best channels to be using for this. And the other approach is analytical. So Carmel and Tom did an experimental setup, and they used an ordinary photographic light meter. They also got a factor of 4 brightness difference. Carmel went as far as deriving, using calculus and researching the appropriate formula, looking at secondary wavelets and their superposition on the screen, and derived also the factor of 4 difference. So fairly conclusive evidence that the relationship is a square relationship and not a linear proportional relationship. However, I'm really interested in your comments. So if this is an exam question, if the mark scheme produces the wrong answer, was it just a typo? Is there a difference of opinion in the IB universe? What should students do if faced with a similar question in a future exam? Let me know in the comments. Let's spark some debate in this. Let's get some opinions. And if possible, I'd like to follow up soon with another video if we do get the debate going. So that's all for now. And if you are preparing for IB exams, don't let one little detail throw you. If you are well prepared and study hard, you'll do well in the exams, and all the best of luck to you.